Welcome to the deep dive. Today we're tackling a topic with a surprising twist. Fluoride. We mostly know it for helping our teeth, right?
hmm
But too much of it in drinking water. That can lead to something pretty serious called skeletal fluorosis.
That's exactly right. Fluoride's great for dental health in the right amounts, but yeah, too much is where the problems start.
So our mission today.
We're doing a deep dive into this issue globally,
Mm.
looking at excessive fluoride in drinking water, focusing specifically on skeletal fluorosis, what causes it, where it's happening, and crucially, what can actually be done about it. We've reviewed quite a bit of research for this.
Okay, fluoride. A bit of a double-edged sword then. It is essential for growth, especially bones and teeth.
Oh, absolutely. It's a trace element we need.
Mm-hmm.
And there's a sweet spot for drinking water, usually around zero point 0.5 to 1.0 parts per million, or ppm.
That's the level good for preventing cavities.
Exactly, that's the beneficial range.
But cross a line and it becomes toxic.
Precisely. When you consistently consume water with fluoride levels, say above 1.5 ppm, that's when you start seeing the risk of fluorosis really increase.
And where's all this extra fluoride coming from? It's not like people are adding it everywhere.
Well, mostly it's naturally occurring. Fluorine is actually pretty abundant in the Earth's crust, in rocks and soil.
So it gets into the groundwater.
Yes, that's the main pathway. So the fluoride level in your drinking water often depends heavily on the local geology.
Ah, geology. So there are specific areas.
Yep.
Belts, you mentioned?
Yeah, that's a good term. There are well-known fluoride belts across the globe. Think Syria through Africa, Turkey across Asia, including India, parts of Thailand, China,
Wow.
and even more recently identified belts in America and Japan, too.
And India seems particularly affected.
Unfortunately, yes. The research we looked at flags about 230 districts across 20 states in India as being at risk from high fluoride levels.
That's a huge area.
It is. States like Andhra Pradesh, Gujarat, Rajasthan are some of the worst hit. But others, like Punjab, Haryana, Madhya Pradesh, Maharashtra, also have moderately high levels.
And there's an official limit in India.
Yes, the Bureau of Indian Standards sets the permissible limit at 1 ppm. Above that is considered potentially risky.
Okay, so water is the main culprit. Are there other sources we should be aware of?
Well, you can get fluoride from food, the air, even using too much toothpaste, potentially. But the research really points to drinking water as the primary source of excessive intake, especially in those high-risk zones.
Right. Now, you mentioned fluorosis, but it's not just one thing, is it? There are different kinds.
Correct. We usually break it down into three main types: dental, skeletal, and non-skeletal fluorosis.
Okay, let's touch on those. Dental fluorosis, that's the one most people might picture. The white spots on kids' teeth.
Exactly. It affects developing teeth in children who've had too much fluoride. It can range from faint lines to more obvious discoloration, even pitting.
But other things can look similar, right?
Yeah, that's a good point. Things like malnutrition or not getting enough vitamin A or D can sometimes cause similar marks on teeth. So diagnosis isn't always straightforward.
And non-skeletal, what's that involve?
This one often starts with gastrointestinal symptoms, like nausea, stomach pain, maybe changes in appetite.
Sounds pretty general.
It is, and that's the tricky part. Those symptoms overlap with so many other common illnesses, it can be hard to pinpoint fluoride as the cause early on.
Which leads us to the main focus of our deep dive. Skeletal fluorosis. This sounds much more serious.
It really is. Skeletal fluorosis is a severe condition. It comes from chronic, long-term buildup of fluoride in the body.
And it doesn't show early signs.
Often, no. That's what makes it insidious. It develops over years, quietly affecting the bones and joints. By the time symptoms are obvious, it's usually quite advanced.
What kind of symptoms are we talking about?
We're talking major joint involvement, neck, shoulders, spine, hips, knees, leading to stiffness, chronic pain, and eventually marked disability.
That sounds debilitating.
It absolutely can be. And importantly, the chronic changes, the damage to the skeleton, it's irreversible. This can severely impact someone's ability to work, to live a normal life. It has knock-on effects for families, communities, even regional economies.
Okay, let's really dig into the mechanics of skeletal fluorosis. What's actually happening inside the body, in the bones?
So basically, skeletal fluorosis is what happens when high levels of fluoride build up in your bones and joints over a long time. This usually comes from drinking contaminated water, but sometimes even inhaling fluoride dust can contribute.
And this buildup messes with the bone's normal processes.
Exactly. Our bones are constantly remodeling, breaking down old bone, building new bone. High fluoride levels disrupt this delicate balance. It interferes with bone resorption, That's the breaking down part. And it also messes with calcium levels in the bone tissue.
So it throws the whole mineral balance
Pretty
off.
much, yeah. It leads to an imbalance in bone mineral metabolism.
And I guess it doesn't happen overnight. Does it progress in stages?
Yes, it's generally classified based on severity, usually into mild, moderate, and severe stages.
What are the signs as it gets worse?
Well, common symptoms across the board are chronic joint pain and stiffness. In the milder stages, you might get pain that comes and goes, maybe some early hardening or calcification of ligaments. And the bones might start becoming denser. That's called osteosclerosis.
Okay, denser bones. That doesn't sound too bad initially.
It sounds counterintuitive, right? But it's an abnormal density, often making the bone more brittle in some ways. As it progresses to moderate, this osteosclerosis gets worse. You might see bony growths forming, and the ligament calcification spreads.
And in the severe stage,
That's where you see really intense stiffness and rigidity. Movement becomes severely limited, especially in the spine and major joints. You can get skeletal deformities, muscles wasting away, sometimes neurological problems if nerves get pinched,
wow.
and really restricted joint movement, severe ligament calcification.
It sounds like it can really take over someone's body.
It can. The inflammation and calcium changes can cause spinal ligaments to harden, even turn into bone. That's ossification. This stiffness can then radiate out to the arms and legs.
You mentioned breathing difficulties too.
Yeah, the rib cage can become affected, sometimes leading to a kind of barrel-shaped chest, which makes breathing harder. In the most extreme cases, joints can fuse completely, leading to fixed, bent limbs, flexion deformities. People can become bedridden.
That's awful. Are certain bones or age groups more vulnerable?
Well, the long bones, especially around the knees and elbows, seem prone to developing these bony spurs or outgrowths called exostosis. And some research suggests the 30 to 50 age group might be particularly susceptible to developing symptoms.
And it's not just about the fluoride level, is it? How long you're exposed matters.
Absolutely. Duration is key. The longer you drink high fluoride water, the higher the risk. But other things play a role too.
Like what?
Like getting older, definitely. Also, not getting enough calcium in your diet seems to make it worse. And just overall, poor nutritional status can increase your susceptibility. Your body's ability to handle the fluoride load is affected.
The research you looked at also brought up something called oxidative stress. How does that fit in?
Yeah, oxidative stress is seen as a really key mechanism behind fluoride toxicity. It's basically an imbalance in the body
Imbalance between what?
between harmful molecules called reactive oxygen species, or ROS, and the body's ability to neutralize them with antioxidants. Fluoride exposure seems to ramp up the production of these damaging ROS.
And these ROS damage our cells.
They can, yes. They're unstable and can damage cell structures, proteins, even DNA over time. Fluoride itself is highly reactive, chemically speaking, and this, combined with the oxidative stress it triggers, can contribute to chronic diseases like fluorosis.
You mentioned mitochondria being a target. The cell's powerhouses.
That's right. Mitochondria seem particularly vulnerable. Fluoride can mess with how they produce energy, how cells breathe, essentially. This damage can even trigger programmed cell death, called apoptosis.
Do we have defenses against this kind of stress?
We do. Our bodies have a whole antioxidant defense system. There are enzymes like glutathione peroxidase and catalase, and non-enzymatic antioxidants too, like glutathione itself, vitamin C, selenium.
But fluoride can overwhelm these defenses.
Exactly. Especially with continuous high exposure, maybe starting early in life when these systems aren't fully developed. It can disrupt this balance, leading to more oxidative stress and less protection.
Okay, so that's the mechanism. The review then highlighted some recent case studies, right? To see how this plays out in the real world.
Yes, exactly. The first one was from Iran, looking at 5 villages.
And they had different fluoride levels.
Yeah, quite different. Some were okay, but others had really high concentrations in the drinking water, up to over 10 ppm, which is very high.
Wow, and what did they find?
They screened over 400 people and found that in the high fluoride areas, about 21%, that was 94 people, had skeletal fluorosis.
21%. How did that compare to the low fluoride villages?
Is about 9 times higher. A huge difference, clearly linking the water fluoride levels to the prevalence of the condition.
How did they actually check for skeletal fluorosis in that study?
We started with some basic physical tests like, can you tuck your toes without bending your knees? Can you stretch properly? Difficulty with that suggests stiffness.
Simple checks for flexibility.
Right. And then they confirmed suspected cases using x-rays, looking for those characteristic changes in bone density and structure.
Did they notice any patterns, like age or gender?
Interestingly, yes. In that specific Iranian study, it was much more common in older people, those over 70. About 54% of that age group were affected. And they also found it was more frequent in women.
And more in women. That's interesting.
It is, especially because it contrasted with another study they mentioned from Rajasthan in India. There, skeletal fluorosis was actually more common in men, and it peaked in a slightly younger group, the 55 to 64-year-olds.
Huh. So different patterns in different places. Any idea why?
Well, the researchers suggested several possibilities. Diet could be a factor of differences in calcium or vitamin C intake. Also, the water chemistry itself, maybe things like alkalinity, could play a role alongside the fluoride level.
So it's complex, not just fluoride fluorosis.
Definitely not. It highlights that we need more research to really understand these influences, like gender differences.
Okay, and there was a second case study, also in India.
Yes, in Maharashtra state, in a village called Pimpalgaon. There, the well water had fluoride levels around 4 to 4.5 ppm, still quite high.
What did they find there?
They screened about 2,500 people and found 204 individuals who had either skeletal or dental fluorosis,
So an overall prevalence of...
just over 8%, which is still a very significant health burden for that community. The study also noted that affected individuals showed significant changes in blood tests and other biochemical markers.
Did they say how many had skeletal specifically?
Not the exact breakdown in the summary we reviewed, but the overall figure clearly points to a major problem linked to the water source.
Okay, so it's clear prevention is absolutely key, especially since you said there's no real cure for the skeletal form once the damage is done. What can be done to lower fluoride in the water?
Right, prevention is paramount. Ensuring safe drinking water is the goal. The review points to two main approaches: treating the water at the source, like a community well, or treating it right in the home.
Let's talk treatment methods. Reverse osmosis, or RO, was mentioned.
Yes, RO systems use a special membrane to filter out fluoride very effectively. They're quite common now.
Are there other, maybe lower-tech options? I think activated alumina was mentioned.
Yeah, IIT Kanpur and UNICEF developed some defluoridation units using activated alumina. It works by adsorption. The fluoride sticks to the alumina material. They have units for hand pumps and also smaller domestic ones.
Are they cost-effective?
They're generally considered more cost-effective for smaller scale use and produce less waste or sludge compared to some other methods.
Okay. What about the Nalgonda technique? That sounded like it's been around a while.
It has. The first plant using it was set up way back in 1961 in Nalgonda, India. It's a chemical precipitation method.
How does it work?
You add aluminum salts, usually a lemon lime, to the water. Then you mix it rapidly, let it slowly form clumps or flocculate where the fluoride binds to the aluminum compounds. Then you let those clumps settle out, filter the water, and disinfect it.
Sounds like a multi-step process.
It is, but the advantage is its versatility. You can adapt it for household use with buckets, for community water points, or even for larger municipal treatment plants.
Then there was the IS6 technique from the Indian Institute of Science.
Right. That one uses a mix of magnesium oxide, calcium hydroxide, and sodium bisulfate. The key reaction is the magnesium oxide reacting with fluoride to form magnesium fluoride, which doesn't dissolve in water, so it precipitates out and can be filtered off.
And they developed a unit based on that.
Yes, in Kolar, Karnataka.
And finally, the two-bucket technique. That sounds very practical.
It's designed to be simple and low cost for home use. You have two buckets, basically. You add the lemon lime to the first one, mix it, let it settle.
Okay.
Then you carefully pour the clearer water through a cloth filter into the second bucket, which has a tap. Using two buckets helps prevent the settled fluoride sludge from getting stirred up again.
Simple, but hopefully effective. It's good there are options.
Yeah.
Are these techniques actually being used in larger programs to help people?
Yes, thankfully. There are examples both globally and within India. In Tanzania, for instance, in Gurdodo village, they implemented the Nalgonda technique.
How did that go?
It was seen as cost-effective and manageable. But they did run into some issues. Sometimes the fluoride levels didn't get quite low enough, and using lime tended to raise the water's pH quite a bit, which can be another problem.
Right. And what about that mobile bus project in Thailand? That sounded different.
Yeah, the ICOH mobile bus unit. Their focus is more on awareness and community engagement. They travel to affected areas, test the water on site, educate people about the risks, and work with the community to find solutions. They have health professionals on board, too.
That sounds like a great approach. And in India, there's a big national program, NRDWP.
Yes, the National Rural Drinking Water Program. It started in 2009 with the goal of providing safe drinking water across rural India. It's a massive undertaking.
Has it been effective?
Well, it's been implemented everywhere, and it was actually revamped in 2017 to focus more on outcomes, setting a very ambitious goal: universal access to safe and affordable drinking water by 2030. So the effort is definitely there.
Are there smaller, more targeted projects in India, too?
Oh yes, lots of state and local initiatives,
Mm-hmm.
like Project Sarita in Rajasthan that was a pilot using both Nalgonda kits and activated alumina filters plus awareness campaigns.
Okay.
Then there's the Sachitana Plus project in Karnataka, focusing on rainwater harvesting and groundwater recharge to reduce reliance on high fluoride sources.
Smart.
Uttar Pradesh has a project in Sandhadra doing health assessments, water monitoring, and awareness. Orissa has collaborations happening. Madhya Pradesh combines defluoridation with nutritional support in their program.
Nutritional support. That links back to what you said earlier about diet playing a role.
Exactly. And some places, like Gujarat, have implemented large-scale, long-term solutions by actually piping in surface water from rivers and reservoirs to bypass the contaminated groundwater altogether.
It really shows there's no single magic bullet. It takes a combination of approaches. So as we wrap up this deep dive, what are the crucial takeaways for everyone listening?
I think the main thing is understanding that fluoride is complex. Beneficial in small amounts, yes. But excessive fluoride, mostly from drinking water, is a major global health issue.
And skeletal fluorosis is the severe end of that spectrum.
Right. Leading to chronic pain, disability, and it's irreversible. While there's no specific cure, cutting off the fluoride source and improving nutrition, focusing on protein, calcium, vitamins, antioxidants, can help manage symptoms.
Antioxidants might even be a potential antidote down the line.
There's research looking into that, yeah. But right now, the lack of awareness and the cost of dealing with it are still huge hurdles.
So more research is needed.
Definitely. We need easier, cheaper ways to treat both the condition and the water itself. And public awareness is absolutely critical. Governments, NGOs, communities all need to be involved.
Like putting it in school curricula, as mentioned in Rajasthan.
Exactly. Educating the next generation is key. Plus, outreach through health camps, training for doctors and health workers, especially in affected areas.
So they can diagnose it properly.
Yes, and advise on prevention. Maybe even looking at health insurance options for people stuck with contaminated water sources. It really requires a multi-pronged approach. Proper training for healthcare staff is vital for early diagnosis and prevention advice.
That's a huge challenge. Okay, so thinking about everything we've discussed, the widespread impact, the irreversible nature of severe skeletal fluorosis, the lack of a simple cure, here's a final thought for you to ponder. What truly innovative, accessible solutions could we develop and roll out globally to really get a handle on this problem and make sure everyone, everywhere, has safe water to drink?
That's the million-dollar question, isn't it?
It certainly is, something that definitely needs ongoing focus. Thanks for joining us for this deep dive.